Hello friends, I, BHATIA, welcome you to my YouTube channel Maths DNA from Origin to Infinity. In this video, I am going to share with you the questions for practice for real analysis that can be useful for any competitive exam such as CSIR-NET, GATE, SET, IIT-JAM, NBHM, NBHM P.Hd and any other M.Sc entrance exams. I have already conducted a free test series on linear algebra and more than 100 students have already appeared in that. They demanded next on real analysis. So here it is. The questions are: first, which of the following function is not differentiable at x equals to 0? And the options are A. fx is equals to sine mod x into x, B. fx is equals to sine x square if x belongs to Q, that is set of rational numbers, and 0 otherwise. C. f of x is equals to sine mod x if x belongs to Q and 0 otherwise. And D. None. Here you need to take care that in the question it is asking that which of the following function is not differentiable. Don't be in a hurry and read the proper question so that you can understand it clearly. For this, you need to first go through the topic of differentiability and then use its definition, then you can easily solve this. Second, which of the following functions are uniformly continuous over their respective domains of the definition? The first one is fx is equals to summation n running from 1 to infinity g of x minus n upon 2 raised to n, where x belongs to R and where g is from R to R, that is set of real numbers to real number, is a bounded and uniformly continuous function. Second, f of x is equals to cos x into cos pi by x, where x belongs to open interval 0, 1. The third, that is both a and b are true, and C, neither A nor B is correct. So for this you need to go through the topic of uniformly continuous over their domains. Moving on, the third question is which of the following function is not continuous at every point of their respective domains of definitions? And the options are A. f of x is equals to limit n tends to infinity x square into e raised to nx plus x upon e raised to nx plus 1, where x belongs to R, the set of real numbers. Option B. fx is equals to limit n tends to infinity x square into e raised to nx plus cos x upon e raised to nx plus 1, and where again x belongs to set of real numbers. Option C. Limit n tends to infinity 1 upon n log e raised to n plus x raised to n, where x is greater than equals to 0. And D. None of them. And yes, for the solutions of this question, the link is given below in the description box. You can register over there and get the solutions. Fourth, let f of x is equals to e raised to 1 by x. In which of the following domains is it uniformly continuous? Again, an important question on uniform continuity. And remember, this topic is very important as questions are asked from this topic each and every year. The options are A. Open 0, 1, B. Open 1 to infinity, C. Open 1, 2, and D. All of them. The fifth question is let f be a function from R to R, be a continuous function, and let B belongs to R. Then evaluate limit h tends to 0, 1 upon h integration b minus h to b plus h ft dt. And the options are A. f of b, B. 2f of b, C. 3f of b, and D. 4f of b. This is a very useful formula for limit also, so you must be knowing its solution. Sixth one, which of the following statements are false? Now see, when such questions are asked, you need to go through the statement very clearly and so that you don't make a mistake. The first statement is let f from R to R be such that f of x plus y is equals to fx plus fy for all xy belongs to R. Now if ft is greater than 0 for all t greater than 0, then f is continuous. Option B says let f from R to R be such that f of x plus y is equals to fx into fy for all xy belongs to R, and if f of x is greater than or equals to 0 for all x belongs to R. The third is C. Let f from R to R be a continuous at x equals to 0 and such that f of x plus f of x by 2 for all x belongs to R. Then f of x is equals to 0 for all x belongs to R. In the second option, it is written as if. It will not be if, it is then f of x is greater than or equals to 0 for all x belongs to R. There is a printing error, and the last option is none of them. Read the options very carefully and then give your answer. Yes, you can definitely comment your answers below in the comment box. The seventh question is, which of the following functions are uniformly continuous on R? One more question on uniform continuity. So you might be able to now understand that this topic is very important. First is A. fx is equals to x square. B. f of x is equals to integration 0 to x gt dt, where g from R to R is a continuously differentiable function. And C is again f of x is equals to integration 0 to x gt dt, where g from R to R is a continuous function which is bounded. Now you can see option B and option C look so similar, but they are different. So make sure that you are able to understand the difference between the options. And option D is again none of them. Option 8. Let fx is equals to mod x raised to pi by 2, where x belongs to R. Then which of the following statements are true? The options are A. The function f is not differentiable at x equals to 0. B. The function f is differentiable everywhere and f dash x is equals to pi by 2 mod x raised to 3 by 2. C says the function f is differentiable everywhere and f dash x is equals to pi by 2 into mod x raised to 1 by 2. Here also option B and option C are so similar, just there is a difference in the power of the mod x. And D says all of them are true. I again repeat, for the solutions you can find a registration link in the description box below, and you can comment your answers below in the comment box. The ninth is, for f of x is equals to 0 if x belongs to Q, the set of rational numbers, and x square minus 1 if x does not belong to set of rational numbers. Then the points of continuity of the function f are first minus 1, 0 and 1, B minus 2 and minus 1, C minus 1 and 0, and D minus 1 and 1. Now this question is so important that it has been continuously asked in most of the competitive exams, and many students make mistake in this question. So I have one more question on this topic, that is 10th. Find the points where the following function g from R to R is continuous. The gx is given as 0 if x is rational and sin mod x if x is irrational. And the options are A. n pi, where n belongs to the set of natural numbers, B. k pi, where k belongs to set of integers, and C. none of them. You can comment your answers below in the comment box, and for the solutions, that is detailed solutions, you can register yourself in the link given in the description box below, and also give the linear algebra test series that is available for free, and you can find a video on that, and be a member of our social club and check out more than 160 videos on our YouTube channel to get a complete study material on our Telegram channel.